this video, we're going to be finding p-values. And so let's just make sure we're all on the same page of what a p-value is. A p-value is either an area of a relevant tail, or it's 2 times the area of a relevant tail. So p-value is always going to be a positive number. Now, when do you use area and when do you use 2 times the area? You will have just the area of the relevant tail if you have a left or right tail test. And you'll use 2 times the area of the tail if you have a 2-tailed test. So that's a good way to help remember it. And since a p-value is area or 2 times area, we're going to take that to 4 decimal places is the convention. So we're going to go through these 5 questions, and I'm going to start with that first one. I'll just come down here where I've got the first one set up. All right, so straight from the get-go in this problem, you're told that you have a left tail test. So the p-value is going to be the area in this left tail. Okay. That'll be our p-value, the shaded area. Now, the test statistic is a z-score. So now to get the area of this shaded region, since my test statistic is a z-score, I'm going to need to use the command normal CDF. And I'm going to need to tell it the left z-score. Now, in theory, this goes on forever. So in theory, the left z-score would be negative infinity, but it doesn't do negative infinity on our calculator. And then the right limit here, my right z-score is minus 1.83. Now, if I'm using an older calculator, that would be all I would have to tell it. So I'd get into, so this is an 83 plus, which in many ways is easier than these newer models. I just get into second vars, come down here to normal CDF, and then tell it the left limit, which is, I'm going to give it a really large negative number, comma, and then minus 1.83. And then I'm going to press enter. And if I take that to 4 places, then that's going to be that answer there. Okay. But now suppose I want to, suppose you have one of these more newfangled calculators. Okay. It's still going to be the same command, and you still get there the same way. So I'm going to do second vars, and I'm going to come down here to normal CDF. Now it takes you to this page. Now this is the default, and that's your left limit. And the default is a number that's, you know, heading off to negative infinity. So I don't need to change the default on this one. And then my upper limit or my right limit here is going to be minus 1.83. And of course, we're in a standard normal distribution, so those are just part of it. And then I press enter. So the calculation was actually shorter on the older model, but never mind, never mind. Okay, so I can get rid of this one now, and let's look at question 2. So I'll just take a screenshot of question 2, and we'll get started on that one. All right, I'm going to come back down here. And so this one says, find the p-value for testing the null hypothesis, H0 is p is equal to 0.2, and the alternative hypothesis. Now, in this one, we can see that the symbol of the alternative hypothesis is the not equal symbol. And so because it's the not equal symbol, it's going to be a 2-tailed test. And I have a test statistic, and it's negative. And again, it is a z-score. So since I have a two-tailed test, my area is going to be 2 times this shaded region. And since my test statistic is a z-score, again, I'm going to use the normal CDF command. Now, what I like to do in my calculator is I like to do the 2 times first, so I don't forget. So 2 times the normal CDF, and of course the left z-score here, or the lower limit, is minus infinity, and the right limit here, the right z-score, or the upper limit, is minus 1.11. So on an older model, that's all I would have to tell it. So over here, I'm going to do the 2 times first, so I don't forget it. Then I'm going to do second vars, and then come down here to normal CDF. Now, it's got my information from the previous problem in there. And so again, my left limit is going to be going off to negative infinity, or the lower limit. But now the upper limit, or the right limit, my right z-score, is minus 1.11. Then I'm just going to come down here to paste and press enter. And that gets me back to the main screen, and then I'm going to press enter. And if I take that to 4 places, then that 9's going to bump that up to that. Okay, and so my answer is going to be B. Now, here's what happens if you don't do the 2 times in the first. People think, oh, I'll do the normal CDF command, and then I'll multiply it by 2. And what happens most often is they forget. They just forget. They'll do second vars, and they come down here and put that same information in, and then forget to multiply it by 2. And then you can see when you take that to, in this case, 3 places, it's going to give you the wrong selection. So they're really testing you there to make sure, first of all, you know that it's a two-tailed test, because the symbol in the alternative hypothesis is not equal. And if it's a two-tailed test, it's going to be 2 times the relevant region. Okay. All right. So let's go to the third question. All right, let me take a screenshot of that, and then we'll get we'll put it on the next page so we've got room. So I'm just going to come back down here and put that there. Might need to make it a little bit bigger for everybody to see it. Okay, the weights of discarded plastics from a sample of 51 households are recorded. A hypothesis test for the claim that the mean weight of discarded plastics from all households is greater than 1.8 pounds yields a test statistic of. Okay, so we got a lot of stuff going on here. So the claim, my claim in symbolic form, is that the mean is greater than 1.8. So if I were to do the null hypothesis you always write with an equal sign. And then when I get down to the alternative hypothesis, I look at the original claim, and that symbol is allowed. You're allowed strictly greater than, strictly less than, or the not equal sign. So it's allowed, so I keep it. And because the symbol in the alternative hypothesis is the strictly greater than symbol, I'm going to use a right-tailed test. So what we've got going on now is we're going to have a right tail. And that's where my test statistic is going to be. Let me get this all colored in. And so my p-value is just going to be that shaded region. So for right tail or left tail, it's only the shaded region. You only multiply it by 2 if it's a two-tail test. Now, the next bit of information here is that my test statistic is a t-score. So I cannot use the normal CDF command. What I'm going to need to use if we have a t-score is, let me get here to, actually let me clear this on the screen. Second vars, and we want the tcdf command. So my p-value is going to be equal to tcdf. Then I have to tell it the left t-score, the right t-score, and then I have to tell it the degrees of freedom. Now, what are the degrees of freedom? Degrees of freedom is going to be n minus 1, where n is my sample size. And so my degrees of freedom are 50 for this problem. So if I look at this, my left or my lower limit here, t-score is 0.744. My right one, well, in theory, this goes off forever. So I can't put an infinity in there, so I'm going to just give it a really big number. And then my degrees of freedom are 50. You must always give degrees of freedom whenever you're doing anything that involves t-scores. Okay, and again, if I just had an older model, that would be a really straightforward thing to do. Second vars, come down here to TCDF, and 0.744, comma, then the right one is 10 to the 99th, comma, and then 50 is my degrees of freedom. And if I take that to 4 places, so answer, p-value is 0.2302. Okay. But if you're using one of these newfangled models, okay, then we're going to do the same thing. Second vars, we're in there, and I'm going to come down here to TCDF. Then I'm going to press enter. Now you can see that the default is minus infinity, going off to minus infinity. And here we're going to have change default because my lower or my left t-score here for this shaded region is 0.744. And then I'm going to press enter, and then the upper or the right limit in this picture is technically infinity, but I'm just going to give it a really large number because there's not an infinity button that I can press. Then enter, and then the degrees of freedom are going to be 50. Enter, and then enter again. And it gives us the same screen we had in the older model. Then I'm going to press enter, and I get the same answer. Okay. All right, let's keep going. So I can get rid of this, and let's go back up here. We're up to question 4 now. Put that up there. So let me take a screenshot of question 4 and get some more room to work on this down here. Okay, so might want to make that a little bit larger. There we go. Okay, while conducting a hypothesis test for the claim that the proportion of zeros in randomly selected numbers equals 10%. Okay, so the claim in symbolic form is that the proportion of zeros in randomly selected numbers equals 10%. And so if I write my null hypothesis, it's always the original claim written with an equal sign. But now when I get to the alternative hypothesis, I look at the original claim and the equal symbol is not allowed. for the alternative hypothesis. So if you have a symbol that's not allowed, you take its complement. So what I will need in the alternative hypothesis is P is not equal to 0.1. And now I have the type of test. Since I have a not equal sign in the alternative hypothesis, I'm going to be using a two-tailed test. If you're using a two-tailed test, the p-value, oh, and my test statistic is a positive number, so that's why I drew it over here, because I was already looking at it. It's a z-score. So since this is a two-tailed test, my p-value is going to be twice this shaded region, twice the tail. So 2 times the shaded region. And I have a z-score there, so again, I'm going to have 2 times, and since I'm working with a z-score, I'm going to use the normal CDF command. And if I go from left to right, my left limit here is z-score of 2.003, and there's technically no right limit. That keeps going off to infinity, but I'm just going to put in a really big number. And of course, with the z-score, that's all we need. We only need degrees of freedom if we're talking about t-scores. So I'm going to put that into my calculator now, 2 times. And then I'm going to get into second vars and come down here to normal CDF. And so I am starting at, moving from left to right, 2.003. So that default needs to be changed here. Enter. And then my right, or my upper limit here is going to be a really, really big number. Technically it's infinity, but there's not an infinity button. And then we're in a standard normal distribution, so I'm just going to do paste, and then I'm going to press enter. So when we get that, my answer is the p-value is, and if I cut that off at 4 places, and that 7 is going to bump that up to a 2.0452. Okay. All right, and for the last question, let me get rid of this, and we'll just copy question 5. Okay. Let me copy it and move it down here. All right. So let's move him down. Okay. A sample consists of the ages and years of 16 randomly selected race car drivers. A hypothesis test for the claim that the mean age of all race car drivers is less than 35 years yields a test statistic of t equals minus 1.724. What is the p-value? So when I'm giving a test like this, a lot of times, alarm bells if students give a negative p-value. Okay, they're getting it mixed up with the critical value. And a p-value is an area or twice an area. It will always be a positive number. So what we got here, what's the claim say in symbolic form? It says that the mean age of all race car drivers is less than 35 years. And so, of course, the null hypothesis would be the equal sign. But then when we come to the alternative hypothesis, we look at the symbol in the claim. This symbol is allowed. The alternative hypothesis can have strictly less than, strictly greater than, or the not equal symbol. Since it's allowed, we keep it. And now, since the symbol in the alternative hypothesis is the less than symbol, we're going to have a left tail test If we have a left-tailed test, then the p-value is just going to be equal to the area in the left tail. So just this area, this shaded region. That's what my p-value is going to be. Just this shaded region. Now, what is my test statistic? It is minus 1.724, and it's a t-score. So if you're dealing with a t-score and you want to find this shaded region, you have to use the command tcdf. And you have to give it a left limit here, a left t-score, and of course that's going out to negative infinity. So I'm just going to give it a really large negative number. Then the right limit here is minus 1.724. And then anytime you're dealing with t-scores, you have to supply the degrees of freedom. So our sample size is 16, so our degrees of freedom are going to be 15. And then that's going to be my p-value. Okay, so again, if I use the older model, I'm just going to get into second vars, come here to TCDF, minus 10 to the 99, comma, minus 1.724, comma, and then the degrees of freedom. And if I take that to 4 places, then I'm going to have 0.0526. So that's my answer. And now if I go to the newfangled one, second vars, come down here to TCDF, and should be getting the same answer. And I will go with the default. It's saying it's going off to negative infinity for the left or the lower limit, and the upper limit or the right limit here is minus 1.724, sorry. And the degrees of freedom are 15. And then I'm going to click enter. Okay, and I get the same answer. Okay. All right, so I hope out of those 5 examples that's enough for you to get an idea of how to calculate p-values. So if you like this video, give my page a like and subscribe, and we'll see you on the next one. Have a mathematical day.